Hello friends, in previous lecture we have solved some examples from exercise 3.1 on convergent and divergent series. In this lecture we will study special type of series with non-negative terms. Series with non-negative terms means we will only talk about the convergence and divergence of the series in which every term is non-negative, means it is greater or equal to 0. Okay. So, we will take the theorem. Let summation n equal to 1 to infinity be series of non-negative terms, and Sn is equal to a1 plus a2 plus an for every n. Then A, if Sn is bounded, implies is summation an is convergent, and B, Sn is not bounded, implies is summation an is divergent. Okay. So proof: since summation of n is series of non-negative terms, therefore n's are greater or equal to 0 for all n. Sn is equal to a1 plus a2 plus dot dot up to an for every n, implies Sn plus 1 is equal to Sn plus am plus 1. This must be greater or equal to Sn, since am plus 1 greater or equal to 0. This implies Sn n equal to 1 to infinity is non-decreasing sequence of non-negative terms, non-negative real numbers. A, if Sn is bounded, then Sn is non-decreasing bounded above sequence, implies Sn is convergent, and therefore summation of an is convergent series. Okay. B, if Sn is not bounded, n equal to 1 to infinity is not bounded, then Sn is divergent. Sn is increasing, non-decreasing and not bounded above, implies Sn tends to infinity as n tends to infinity, and therefore summation of n diverges to infinity. Okay. On same line, I can talk about the series of non-positive terms also. So if summation of n is a series of negative terms and Sn is the nth partial sum, then whenever Sn is bounded, then summation n is convergent, and if it is not bounded, then it is not bounded below, so it must approaches towards minus infinity. Okay. So depending on this, we'll take reasons. Theorem. For 0 less than x less than 1, summation of x raised to n equal to 1 to infinity converges to 1 upon 1 minus x. Okay, 0. 1 upon 1 minus x. And b, for x greater than equal to 1, summation of x raised to n equal to 1 to infinity diverges to infinity. A, for 0 less than x less than 1, for series summation x raised to n equal to 0 to infinity, Sn is equal to 1 plus x square plus dot x is up to x raised to n minus 1, which is equal to 1 minus x raised to n upon 1 minus x. And therefore, so this is series of positive numbers. Sn is equal to this. Therefore, limit n tends to infinity of Sn and therefore, the summation of x raised to n equal to 0 to infinity equal to 1 upon 1 minus x for 0 less than x less than 1. B, for x greater than equal to 1, Sn limit n tends to infinity of x raised to n is 1 if x is 1 not equal to 0 and it is infinity if x greater than 1. Okay. And therefore, by necessary condition, for convergent series, summation of x raised to n diverges for x greater equal 1. For x greater equal 1. So, summation of x raised to n is convergent for 0 less than x less than 1 and diverges for x greater equal 1. Okay. Next theorem, the harmonic series summation of 1 upon n equal to 1 to infinity is divergent. For series, summation of 1 upon n equal to 1 to infinity is equal to summation an is greater than 0 for all n, and Sn is equal to 1 plus half plus 1 by 3 plus dot etc. up to 1 by n for every n. for every n. So it is series of positive terms where Sn is given by this one. Okay. Now S1 is 1, S2 is equal to 1 plus half is nothing but 3 by 2, which is nothing but one plus 2 by 2, S4 1 plus half plus 1 by 3 plus 1 by 4 is greater than S2. This is your S2 plus 1 by 4 plus 1 by 4, which is your 3 by 2 plus this is 2 by 4, okay, half. S2 is 3 by 2 and it will become 4 by 2, which is exactly, okay, this is your S2 square, S2 raised to 1, okay. So I'll get this is to be 2 plus 2 by 2. If I take S8, S2 cube, S8 is equal to S4 plus, okay, S4 plus 1 by 5, 1 by 6 plus 1 by 7 plus 1 by 8 is greater than, this is greater than that 4, okay, this is just 2, okay, 2 plus 1 by 8 plus 1 by 8 plus 1 by 8, which is nothing but 2 plus 4 by 8, that is half, which is 5 by 2, and this 5 by 2 is written as 3 plus 2 by 2. In general, S2 raised to n is greater than n plus 2 by 2 for every n. Therefore, limit n tends to infinity of S2 raised to n is greater equal limit n tends to infinity of n plus 2 upon 2, which is infinity, and therefore S2 to the suffix 2 raised to n equal to 1 to infinity diverges to infinity, and S to the suffix 2 raised to n is subsequence of Sn. Therefore, Sn is also divergent. Is divergent, diverges to infinity, since as Sns are greater than 0 for all n. Therefore, summation of 1 by n equal to 1 to infinity diverges to infinity. Diverges to infinity. Note about this one. Note harmonic series summation of 1 by n equal to 1 to infinity is a divergent series such that series such that limit n tends to infinity of 1 by n is 0. Is 0. Okay. From this, if limit of n is 0, then summation n may not be convergent. That is, summation n converges implies limit of n is 0, but not conversely. Okay. Means if limit of n is 0, then summation of n may not be convergent. So it is just necessary condition, but it is not sufficient condition. So with this discussion, we will stop our lecture here. Thanks for listening lecture carefully. Bye bye.